Okay, the title concerns the BIM test, but I take the opportunity to present the work of the coming Model Code 2020 in Chapter 20, which is related to bond of steel rebars in concrete. The authors are myself, Giovanni Metelli, who is the secretary of the Task Group 2.5, and John Kurz, who is the former chair of Task Group 2.5, but I'm presenting on the behalf of all the Task Group 2.5 who did a great work for Chapter 20. It is supposed to move, I think.
Down. No.
Down.
Forward.
Okay, good.
Did it move?
Okay, it moved. Thank you. Okay, thank you. There is a completely new organization of the chapter on bond with new items inside. We reformatted basically the document starts with the provisions concerning the anchorages and the laps. Then we have safety calibration according to the huge database we have. We went into the details of the casting position. There is a new part concerning added reinforcement, which is more important, very important now for strengthening. There are new issues concerning transverse length in pre-stressing beams, repair and strengthening, consequences of deterioration, including fire and corrosion, and then we have also some extension for the bond slip behavior, and also a proposal for a new bond test for the reason I will explain. And so basically the chapter is completely reorganized with respect to Model Code 2010, and sometimes we try to introduce the level of approximations, and also there is a new important chapter on the assessment. Okay, this slide shows a comparison between, on the right, about the chapter 6.1 on bond in the Model Code 2010. It started with the local bond slip behavior, but now the Model Code 2020 starts with is more design oriented because it starts with the design of anchorages and lap joints. Then we have the assessment. Okay. We have the assessment, an important chapter on assessment, another chapter on repairing, and then at the end, instead of in the beginning, we have the local bond behavior, which is important also for research, for special applications, but not for the everyday design. And then we have, since new materials, we have seen this morning, new materials are coming into the structural design, we need to make sure that the rules we provide are good also for these new materials. Okay, very quickly, because the time is very short, for the design, regular design of anchorages and splices, basically we have K times the diameter, and for the first level of approximation, and then we have a second level of approximation. And if you want to stay with the first level of approximation, the K parameter basically is given by this. There is a minimum value of K, of course, and there is the end bearing capacity, then there is the basic anchorage length, and if you satisfy, which is usually the case in practice, within these limits, these boundaries, basically it's quite easy to determine the K values, which are given by this table, where we have several factors for the basic anchorage length, for the concrete strength, for the stress in the material, depending on bond and poor bond conditions. And in a very easy way, you can determine how many times the bar diameter must be anchored or overlapped. These are the limits. Then you can move to a better level of approximation, which is level 2, if the first one is not enough, and then the equation is more or less similar, but you have a better determination of the K value based on a huge database coming from FIB and ACI all over the world, by including the main is a semi-empirical equation, which is well explained in Bulletin 72 of FIB, and with a lot of, let's say, probabilistic calculations, and by considering the stress in the bar, by considering the confining actions provided by the transverse pressure, provided by the cover, provided by the transverse reinforcement, depending on the position of the links and so on. These are the limits of approximation, which are the limit given by the database we adopted. Okay, these are more details because we did a lot of work also on the good and poor bond conditions by considering that you have actually a matter is the behavior when you have a short anchorage, another matter is a behavior when you have a longer anchorage, because in that case you have stress, bond stress redistribution. And that's why depending, it also depends on the stress in the bar. So there is basically an important revision of the good and bad bond condition, especially for the parameter reducing or increasing the anchorage length in the poor bond conditions, because we are no longer referring to the bond strength, which is, let's say, a conventional parameter, but not realistic in practice. And we go directly to the anchorage and the splice length. Okay. We move now there are some detailed prescriptions for joints in seismic regions. And I go quickly because there is no time. And then we also, I mentioned about extreme thermal conditions in case of fire, where you have a degradation factor and also a load factor, considering the design load at limit states in case of fire. We have the anchor. This is an important chapter as well, because it refers to bond of bars in existing structures, and very often we have plain bars or twisted bars, and by using the database available internationally, we were able to propose some equation to better evaluate basically what we are trying to provide in case of existing structures, the maximum stress you can apply to the bar existing in the structure. Then we have the case of bonding, because the codes change, as Jos van Raven was mentioning this morning, in not compliant detailing, especially concerning the concrete cover. In that case, we have a reduction factor, which is generally speaking lower than 1, depending on the conditions. Then we have the case of corroded rebars, and even here there is an improvement with respect to the model code 2010, because depending on the corrosion level, which is basically referred to the distributed corrosion with a weight loss, and depending on the case of beams without stirrups or with a certain percentage of stirrups with different concrete covers, we propose a reduction of the maximum stress applicable to the bar if you have corrosion into the rebars. Okay, and last but not least, since new materials are coming into the market, I'm referring to, for example, as Marco was presenting before, fiber reinforced concrete, but also I'm referring to as it was presented before, concrete with recycled aggregates. And you cannot assume that even if the concrete strength is the same, the bond behavior is also the same. That's why we are proposing a bond test for checking the validity of the equations we provide based on regular concrete with regular aggregates. Okay, the existing bond tests are the well-known beam test, which is quite heavy and very expensive to perform, and then also it's not too much realistic because you have a lot of transverse reinforcement for avoiding shear failure, or the very simple pull-out test, but this is not representative of practice because you don't have the bar in tension and the concrete in compression at the crack. Okay, so there are several drawbacks for these two type of tests. I don't go into the details, but you can see here the drawbacks. So the idea is to propose a bond test for, checking the validity of the proposed equation, but also for proposing new equations. For example, if you want to take advantage of the better confinement provided by fiber reinforced concrete, for example, you can do a campaign of tests for demonstrating that you can a shorter anchorage length can be enough. Okay, and basically is a beam-end test with 2 rebars, one in poor casting position and the other in good casting position. We have the reaction. So basically you apply the load here, you have the reaction here. It simulates a beam under bending, and you can make the specimen as long as you want in order to reproduce the anchorage length you need. And okay, this is what we are proposing. You see here a picture of the experimental setup of a specimen ready to be tested. Basically, the idea is to check if you are using a new material with a minimum of 6 specimens, just for checking if the rules you are using according to the chapter 20 are still valid for this new material you are planning to use. Okay, and that's it. I thank you very much for your attention, and I thank all the group.